Welcome to all of you in this video. In this video we will talk about the modern periodic table. As we know that there was a scientist Lothar Meyer who gave the first periodic law, and he said that the atomic volumes of elements are the periodic functions of their atomic masses, which was later modified by Mendeleev, who said that the properties of elements are the periodic functions of their atomic masses. Then came the scientist Moseley, who said that the properties of elements are based on the atomic configuration, which is ultimately based on the atomic number. On the basis of this observation, he said that the properties of elements are the periodic functions of their atomic numbers. Now, scientist Bohr used this periodic law and formulated a periodic table in which right now 92 naturally occurring and 26 synthesized elements have been placed. This periodic table is called the modern periodic table. Now let's see what else is there in the modern periodic table. See, the modern periodic table has 18 vertical columns which are called groups and 7 horizontal rows which are called periods. Now let's talk about the groups first. Here the elements in group number 1, 2, 13, 14, 15, 16, 17 and 18 are called main group elements, whereas the elements in group number 3 to group number 12 are called transition elements. Apart from this, the elements of group number 1 and 2 are called s block elements because their valence electrons remain in the s orbital. Similarly, the elements in group number 13 to group number 18 are called p block elements because their valence electrons remain in the p orbital. Similarly, the transition elements are called d block elements because their valence electrons remain in the d orbital, and lanthanides and actinides are called f block elements because their valence electrons remain in f orbital. Now what are lanthanides and actinides? Actually, in group number 3, the 14 elements that occur after lanthanum are called lanthanides, and similarly the 14 elements that occur after actinium are called actinides. Now, apart from this S, P, D and F classification, there are 4 groups which have their specific names. These are the group number 1, group number 2, group number 17, group number 18. The elements of group number 1 are called alkali metals because their hydrides and oxides form alkaline solutions with water. Similarly, the elements of group number 2 are called alkaline earth metals because they are mainly found in Earth's crust, and their oxides and hydrides also make alkaline solution with water. Now, the elements of group number 17 are called halogens. Here, halo means salt and gen stands for genesis. So, halogens are the salt formers. When they react with the alkali metals and alkaline earth metals, they form halide salts. Now, the elements of group number 18 are called inert gases because all of them are gases and they are inert, they do not react, their octets are satisfied and completed. Now, so this was about the groups. Now let's talk about the period. So the first period is called the shortest period because it contains only 2 elements. Now the second and the third period are called the short periods. Each of them contain 8 elements. Now the fourth and fifth period are called the long periods. Each of them contain 18 elements, whereas sixth and seventh periods are called the longest period. Each of them contains 32 elements. Now, so this is about the periods. Now let's talk about the periodic properties. So first of all, let's talk about valency. So what is valency? Okay. So valency is the number of electrons lost or acquired to complete the octet of an element. Now, when we move across a period from left to right, the valency first increases from 1 to 4, then it decreases from 4 to 0. For example, the valency of lithium is 1, beryllium is 2, boron is 3, carbon is 4, nitrogen is again 3, oxygen's valency is 2, fluorine's valency is 1 and neon's valency is 0. So when we move across the period from left hand side to right hand side, the valency increases from 1 to 4, then it decreases from 4 to 1. Now what happens when we move down a group? So when we move down a group, the valency remains same. Now the second periodic property is the atomic size, which is also called the atomic radius. What is atomic radius? As the name suggests, it's the distance between the center of nucleus to the last orbit. Now what happens when we move across the period? So when we move across the period from left hand side to right hand side, atomic size decreases. Now it's very interesting fact. Why does it happen? See, what happens each time when we move across the period from left hand side to right hand side, the number of orbits remain same, but number of protons and electrons increase each time. See, for example, in case of period number 3, sodium in the first orbit it has 2 electrons, in the second 8, in the third 1. So actually it has 3 orbits, which is the case with the magnesium, which is the case with aluminium, and which is the case with all the elements in third period. But each time the number of electrons and protons are increasing. In case of sodium, the number of electrons were 11. In case of magnesium, the number of electrons was 12. Similarly, the number of electrons and protons were increasing each time. So because of this increasing number of electrons and protons, the electrostatic force between electrons and protons was also becoming stronger. So because the electrons are scattered, they cannot break the nucleus, but because the nucleus, which is the center of the positive charge, because it is concentrated, it pulls all the electrons towards itself with each increasing step, and the orbits get shrunk. Now when the orbits get shrunk, the radius reduces or the radius decreases. So when we move across the period from left hand side to right hand side, atomic size decreases. Now what happens when we move down a group? When we move down a group, the atomic size increases. Here also there is an increase in the number of proton and electrons, but also with them one more orbit is increasing each time. So because of increasing number of orbits, the atomic radius increases and thus increases the atomic size. Now the third periodic property is metallic and non-metallic characteristics. So now we have to define what are metals. So the elements which donate electron and become positive ions are called metals, and the elements which accept electron and become negative ions are called non-metals. So when we move across the period from the left hand side to right hand side, we observe a decrease in the metallic characteristics, because each time the electrostatic force is becoming stronger and it becomes really hard to lose electrons. So that is why the metallic characteristic decreases when we move across the period from the left hand side to right hand side. What happens when we move down a group? Now see, when we move down a group, we know that each time one orbit is increasing and the atomic radius is also increasing, the distance from the nucleus is also increasing, and because of the shielding effect of the orbits, now the orbits act like barriers, okay, between the electrostatic force of the electrons in the last orbit and the nucleus. So because of this shielding effect, the electrostatic force between the electrons of the last orbit and the nucleus reduces, and it becomes very easy or easier to lose an electron. So metallic characteristics increases when we move down a group, and it decreases when we move across the period. Now here in P block, a zigzag line which consists of silicon, germanium, arsenic, antimony, tellurium, polonium, it separates metals and non-metals. On the right hand side of this zigzag line there are non-metals, whereas on the left hand side there are metals. So this is the metallic and non-metallic characteristics and how do they behave when we move across the period and move down the group. Now we will talk about ionization enthalpy or ionization potential. So first we have to define it. What is ionization potential or what is ionization enthalpy? So actually the amount of energy or the energy which is required to remove an electron from an element is called ionization potential or ionization enthalpy. Now see, an atom can either lose one electron or it can lose more electrons. So the energies required to remove these electrons are called successive ionization enthalpies. For example, see, whenever the electrons are removed or whenever the electrons are lost, they are lost one after another. So because it happens in succession, that is why the energies which are required to remove the electrons are called successive ionization enthalpies. Okay. Now what happens with the ionization enthalpy when we move across the period? As we have seen that when we move across the period from the left hand side to right hand side, the electrostatic force between the nucleus and the electrons is increasing or it increases. So because of this increased electrostatic force, because of this increased attraction, each time it becomes harder to remove an electron and more energy is needed. So ionization potential increases when we move across the period from left hand side to right hand side. What happens when we move down a group? So when we move down a group, the ionization potential or ionization enthalpy decreases, because we know that when we move down a group, each time a new orbit is being added, which is reducing the electrostatic force between the nucleus and the electrons. So it becomes easier to remove an electron using less energy. So that is why when we move down a group, ionization enthalpy or the ionization potential decreases. When we move across the period, it increases. Now the next periodic property is the electron gain enthalpy or electron affinity. What is electron gain enthalpy or electron affinity? When electrons are added in an isolated gaseous atom, some amount of energy is released. So this energy is called electron gain enthalpy or electron affinity. Now we have to keep in mind that the magnitude or the quantity of electron gain enthalpy supports or conveys the capability of the atom to hold an additional electron. So what happens? This electron gain enthalpy or electron affinity increases when we move across the period from the left hand side to right hand side, because each time the electrostatic force is becoming stronger. So because of this stronger electrostatic force, more energy releases when an electron enters an atom, and opposite happens when we move down a group. So this is the fact about the electron gain enthalpy or the electron affinity. Now when we move across the period, the energy released when an electron enters in an atom increases. So we say that the electron gain enthalpy is highly negative, and we say that electron affinity is very high. So if we have to show that high energy is being released, we will say that electron gain enthalpy is highly negative, but we say that electron affinity is very high. And opposite is the case with the groups. When we move down the group, and each time when less energy releases when an electron enters an atom, we say that the electron gain enthalpy is less negative and it is less high, or it is less. That means when you talk about the affinity. So, electron affinity is less and the electron gain enthalpy is less negative. These are the terminologies which are used for electron gain enthalpy and electron affinity. The last one is electronegativity. So, what is electronegativity? Electronegativity is the tendency of an atom to attract the shared pair of electrons in a covalent bond. So, when we move across the period, this electronegativity increases because of increased amount of electrostatic force, and when we move down a group, it decreases. So, in this video, this is it. Thank you.